I have been warned that it's spring break for some of the people still, so we may have a small attendance this week. We'll give it another minute or so and get started. All right. Well, it looks like this is all we're going to get for right now. So welcome everyone to the March OCP Server Project call. Probably be a short call this week because we don't have any extra presentations. Don't think any of our sub-projects are going to have a extremely long update. So it should be a fairly quick call. Alan did, well, first off, for announcements, obviously we have our regional summit coming up next month. We have gotten all the submissions presented for that, and the schedule for that is live online. If you go to the OCP website, you can review the schedule and the subjects of all the presentations. Looking forward to that. I know there's not a lot of people in the US can be traveled to it this year, so it is a regional summit, not our main summit, which will happen in September, October. Let's see, is Greg on? Don't see Greg on. So I don't know if we have a OCP Foundation or steering committee update. I'm surprised Greg isn't here. I don't think there's anything that I have to convey from the foundation or the steering committee. Next up, we have Alan with HPC.
Hi, John.
Present.
Yeah, can you hear me?
Yeah, we can hear you.
Yeah, I do have the full hour now. I rearrange things. So yeah, just maybe a quick update. I've just got my slides from the OCP Regional Summit, so I could quickly go through that if you'd like to get everyone a little bit up to speed.
Sure.
Firstly, as I said before, we've been working towards maybe trying to get some funding from the New Frontiers RFP, but that we understand that's on hold. So we're still gradually working towards pulling all of that together, putting material in the response, and hopefully that'll come back to life soon. If I share my screen a moment. Can you see that? Actually, sorry, let me just share the whole lot here for a minute. So this is the presentation we're doing at OCP Regional Summit. We're just giving an update in the progress we're making towards our open and sustainable energy-centric computing architectures for today's AI and HPC applications. But what I've chosen to do really is the last OCP Global Summit, I gave an overview of the overall modular architecture. So I'm taking the opportunity with Europe sort of more focused on sustainability to dive into some of the specific aspects of what we're trying to do. And very much from a humble perspective of we need a lot of help. So I'll just flip through the slides, but effectively we've just said, hey, take a look at Frontier. How could we build Frontier out of our HPCM module? It would be around 50,000 modules, and we'd merge the storage in the compute together because of the architecture of the module. There's one little module being amplified out of the data center. So that's where I refer to our previous presentations to get a little bit more detail on that. But because we're doing wall of compute, and I thought it'd be nice to compare it to an EU-sized brick. So all in all, we're just another brick in the wall with the HPCM module. I'm just highlighting here that it's composable, domain-specific architecture building block, inspired by the OEM. looking for supporting processors and accelerators and switches that are less than a kilowatt, with support for up to 16 E3.S modules or a number of interconnect instead of those modules. And we have this topology interconnect, so we can configure any domain-specific architecture configuration, like a Frontier machine, like a Grace Hopper connection. And with the potential that we could, we're trying to define a universal interconnect that can take us to up to 8 terabytes per second of co-packaged optics bandwidth for one optical solution that we're looking at. And the idea here is it's scalable from the HPC to the edge. So with the help of ChatGPT, I've shown like a telecom box on the edge of a Lisbon, Portugal street. Not exactly, it's quite a nice picture, but not exactly as we see it, including the tram on the pavement there on the sidewalk. But I'm showing that the module, I'll have an animation here that will show the module could be configured into like 20 modules in a telecom box. So it can go from the data center to the edge of network. And I even got ChatGPT to build a little garage home with the HVAC in hot water system, where on that little piece of silver wall, I'll put maybe 4 modules. So your son's gaming machine can actually be plumbed into the utility, into the architecture of the home, so you don't have an 800-watt gaming PC boiling your son's bedroom. So the idea here is this one open standard takes us from the data center all the way to the edge in various forms. So that's a sort of a view. Then I was going to have a power delivery slide. I've not constructed that one yet, but just to say, when we look at these multiple kilowatts in these boxes, you're seeing huge chunks of copper being thrown in there. The power planes of the motherboards at 2-ounce copper are no good anymore. You get so many losses in traversing long distances with this huge amount of power, even at 48 volts. And so what we show is with the modular architecture, we're literally 2 or 3 inches from the facility power of 300 volts AC DC, whatever the facility power is, to the 0.5 volt or whatever 0.7 volts it drives the silicon. And therefore, by shortening that distance with our modular approach, we can improve power delivery efficiency dramatically. So that I'm going to emphasize that in this slide. Then this slide is on the thermal management side of things. Now, this is a little bit out there in terms of our concepts. It's got a few ideas it pulled from research and industry, but I won't dwell on it. But long story short, each vertical column of 8 modules, so that's roughly 2 kilowatts a module, that's roughly 16 kilowatts. We have a closed loop in that vertical. And we want to use water only for sustainability reasons. We'd like to pull a vacuum, and I'm proposing a liquid ring vacuum pump to about 0.2 bar, which gives us boiling point of water in the region of 60 or 65 degrees C. So we've got energy reuse from that temperature of water. We're also looking towards potentially a University of Illinois Urbana-Champaign piece of research where you conformally insulate the modules and then conformally coat them with copper, where there is a claim that there's from them that there's 7 times more power per unit volume of copper by taking this approach for that. And again, by using water rather than traditional dielectrics like PAO or Fluornut, we could get between 4 to 9 times better thermal conductivity. So, you know, if we put those 3 things together, and again, I am absolutely not an expert here, we could get to 200 times improvement over conventional liquid cooling techniques. There's several control loops in here. There's a control loop per module to make sure that the water eject stays at the 60 degrees C. There's a control loop on the facility water to maintain that reusable energy. And there's a vacuum pump where there'll be a control loop on there to make sure it's pulling the right vacuum all the time. So there's going to be complexity in controlling those control loops and keeping everything stable and functional. So I have no idea whether this will work, but the idea is to get experts to look into this concept and see if it could work. Obviously, water is a huge concern, as I've been told by the experts that join our call. Obviously, it's electrically conductive, hence the conformal coating. Bacterial growth is a huge problem, I understand. But we're really hot temperatures. The temperature of the water used today is in that lovely warm area that bacteria like, but equally bacteria do grow at even these high temperatures in certain regions. We've got corrosion issues that we need to deal with, and is there any water treatment? But that will reduce thermal conductivity and give us more sustainability concerns. So the concept isn't without its challenges on many dimensions, but it's just trying to look at it from a different perspective. So the idea there is to try and pull a bit of expertise in. Then I have hopefully I'll get an animation. I got somebody working on animation to show the water flowing through the module so people can see exactly how the module works in terms of the water flow. And then on the universal interconnect, we're looking to, we've got this world wanting to jump to CPO like a breaker switch from our copper world today. And what we're saying is actually it would be much nicer to have some sort of migration approach from passive copper to CPO. And so we basically listed the idealistic requirements of what we call a universal interconnect. We want to be protocol agnostic. We can talk any of the protocols from the CXL, Ethernet, or any one of the proprietary ones like NVLink, XGMI, InfiniBand, etc. We're fundamentally basing this on the 8-lane copper transceiver approach. So from 32 gig, if you're thinking PCI Gen 5, a speed per lane, up to the 224 that we're seeing emerge today. Sidebands have always been an issue. You don't need them on the likes of Ethernet. There's argued, do you need them or not? But PCI clearly always has them. But it's a lot of legacy stuff that's from the 70s and early 80s, which is damn frustrating at how people have just ignored it all these years. So we're looking at saying, can we make that a bit more efficient? Maybe tunneling protocols like LTPI from OCP. Obviously, we need to have some clocks and maybe just the one DC signal to actually see that a cable is plugged in. But then we need to have active cable options for retimers, active retimer driven cables and optical that less in, around about 10 watts or less. So we need to bring power in. We need a paddle card to support the active components. And most importantly, we need a thermal path from the connector. These are tiny connectors, obviously, like the near ASIC connectors to the water, so we can have an efficient conductive path. One of the things I often sort of joke about is we look at what NVIDIA have just announced, a 1 kilowatt sort of module power, where you look at how small that module is and the 1 kilowatt is pumping through it. Yet in our optical world, we have these QSFP DD cages going to OSFP because we can't get the 10 or 20 watts out of the module efficiency with air blowing over it. So it's looking like something that's only calls 20 watts is the same size. It is approaching the same size as a module that burns a kilowatt. And so, and then if you look at the silicon photonics that's being invented, it's tiny, rattling around inside these cages. So trying to squeeze all this into a universal interconnect that can be near ASIC. And if you saw what NVIDIA were doing with their 224 next to their switch chips on NVLink, they're beginning to cotton on to what we've been talking about for 3 years. But we want to be able to go from passive copper all the way to active cables, copper and optics, near package optics, and also go to co-packaged. In the co-packaged, I've just shown an example. That's a picture of an AVI Senna, an LED optics implementation, where basically we could make an active cable with their technology inside this format. And we've done some little cartoon models with this. Or if we use the same basic shell, we could do a co-packaged version and get 4 of these links they're a terabit per lane, transmit, terabit receive. So we would get 1 terabyte per second per topology interconnector, which would give us the 8 terabytes per second HBM type bandwidth of today off the module. So that would give us a nice migration from one to the other. So that's basically what the talk is all about. I just summarize all of that, and then I say, hey, look, we're working. The challenge with our working group is we need all disciplines to collaborate, and that is a monumental task because everybody loves living in their silos in the evolutionary world, and we're just hoping that the big guys can sort of recognize. I mean, obviously, NVIDIA are doing it all by themselves. They're making progress while being evolutionary, but maybe maybe we could consider this for OAM version 3, maybe in terms of trying to leap a little bit ahead of where NVIDIA is at, rather than chasing what they're doing by copying them. So that's my update. John, take any questions.
All right, thanks, Alan. Definitely some things in there that won't work, but you've got to reach beyond what will work to find that line, right?
Yeah, look, I want to emphasize, I have no expertise. I'm a systems guy, and all the experts on our call, they're fun conversations explaining why stuff doesn't work or won't work, but equally saying, digging into some of these interesting ideas. So yeah, we got a long way to go for sure, but if you don't push the bangs, you're not going to get anywhere.
Yep. All right. Anybody have any questions or comments for Alan? All right. Next up, we have a ODSA update, and it sounds like we have a new ODSA co-chair or a co-lead volunteer. So Jawad, do you want to share or do you just want to talk?
Yes. So I think it's saying you have to unshare before I can share.
Oh, you're right. Yeah, I don't see Anu on. Is he on?
Anu, are you online?
I am.
Okay, so I'll just briefly give the updates in the last month. So first one, let's welcome Anu Ramamurthy from Microchip. She is joining me as the ODSA co-lead, and that's a big help given the amount of activity that's going on. So there are few key points that we wanted to mention today that we have done. So we did hold business workshop with the title of Reducing Barriers to an Open Chiplet Economy. And that was conducted in 2 parts on March 15 and March 22nd. So about 30 to 40 attendees and 40 companies presented. I'll circulate the link for these YouTube videos if you are interested in watching any of those presentations. They're pretty fascinating because they were very much focused on business issues that need to be solved, and we collected some new ideas and now are thinking about some of those. In particular, there's quite a bit of demand that we do work on a die-to-die interface standard for edge AI, for embedded and automotive systems. So that is something that Anu is focusing on. We will be participating in the regional summit in the Innovation Village. Some of the companies from ODSA will be there. One other key thing, the ODSA will get rebranded as sub-project Open Chiplet Economy after the OCP regional. So that is a decision to change the name is with Cliff. When foundation feels like the right time, they will make the switch. But pretty much everybody has agreed to making the switch, and we're slowly talking about the term Open Chiplet Economy. We do have a request from a significant industry partner to set up a chiplet EDA workshop before Design Automation Conference. And we have a work stream called Chiplet Design Exchange, which primarily works on EDA, and it got quite a bit of traction, in particular from Intel. So we are now thinking and planning this next thing. There is also a workshop being planned at Lawrence Berkeley Lab right after Design Automation Conference. And one interesting thing, which Anu probably can talk a little bit more about, we are launching a HPC chiplet modularity work stream. And that's an activity that Anu is involved in. So Anu, you may want to give some update on that if you like.
Sure. So this started off as an effort sponsored by the NIST in conjunction with UCLA Chips. And the idea really is if you can design a system with a reasonable amount of modularity, and we targeted HPC systems because as evident to most people, those are the ones that find that going into chiplets gives them the best bang for the buck. So the idea was if you can come up with maybe two types of systems, so to make it extremely simple, a large and a small system, and then you define within that system certain parameters within which you should fall. So the CPU needs to be this form factor, the memory needs to be this form factor, the IO, the NOC, all the pieces that need to connect the system together. And that needs to sit on a package of such and such form factor with such and such heat sink capability. You basically define a system upfront that would enable the people who make the chiplets to design to a specification, knowing that it's going to fit into a system that's going to be used by more than one person. The goal of this, when it started with the government, the NIST, was they wanted to be able to build an advanced packaging capability in the United States. And in order to do that, you would have to get rid of a lot of the custom one-off types. How do you get to a point where more people use a similar type of manufacturing such that it can be done in high volumes, reducing the cost? So modularity, designing a package that is modular for a small and a large, designing the chiplets that go into that package for a large and a small type of application is what the target was. So that was published officially through the NIST. It's the link that I have is through the UCLA website. It's a pretty long paper. A lot of work was done through John Shaw from LBL, and that is now continuing. LBL through the DOE is taking the lead on this modularity, and we actually have a meeting with them today to see what the plan is and what a potential agenda and what the interest from industry would be. There is interest from industry. The big guys who do the CPU, GPUs have been talking to us, so we'll see where that goes. Thanks, Javad.
Thank you. That's all, John, from us.
All right. Thank you, Javad. Next up, we have Damien, OCP NIC sub-project update.
Sure, let me share my screen. Okay. Today will be a quick one from OCP NIC. There are some discussion where they had in our monthly meeting, but there's some of it I think we need to do additional discussion before we bring it back to the server group. So one of it is regarding the DSFF form factors. So we have decided to propose that the DSFF form factor will be a bit different from our SFM and LFF offering, whereby we will need to keep the outline the same for mechanical reasons, because like DSFF we are thinking about to support a heavy card and might have a heavy heat sink. And in the past, that we do allow like the gold fingers to be missing, and also it's not connecting to the connectors. Like for the small finger, you can have a 2C, and then the larger finger, you have something that one of the gold fingers are actually missing mechanically. So we're thinking for this particular, we'll be doing in such a way that all of the cartridge, the features have to be present. We are considering whether the for cards that doesn't require like for example 32 lanes of PCIe, whether they can reduce gold fingers just for the reason of like cost saving consideration. We don't need a hard go on those if we don't need it, but we are considering. So it is something that from a server group, if you have any thought about one way or another, let us know. This is mainly coming from the NIC card vendor perspective. Like, yeah, if they don't need, they might not want to have like the gold fingers on the pads. We look into it, like if we don't need it, as we have one side of the gold finger, we should be able to detect the card is fair because we only need 4 present pins to do so. Yeah, we have not decided on this. So this is regarding the card edge. Then the second part is like most of the folks that we're discussing in the OCP NIC has been thinking about removing the large form factor from the spec. I think ultimately we align to we'll be moving to appendix, like basically still keeping it in our spec because it's hard for us to reach out to everyone to ensure that the large form factor is not being used before we move to the spec. But we do know that DSFF is actually something we're going to push, and we want to try to deprecate the large form factor. One way to do it is to move to appendix, so we still have it in case there are some legacy cards that are still using the form factors that we are not known of. So yeah, from the server groups, if you have a concern on this, we'd like to hear from you as well.
Yeah, does anybody on the call know if there's any LFF designs out there in the field in production? Yeah, I'm not aware of any either, so moving it to the appendix sounds like a good idea.
Mm-hmm. Yeah. Well, on behalf of Meta, we do have design that is LFF capable, but then never have used. So we have also no much concern to move the appendix. And then the next part will be regarding the mechanical for the DSFF. So last month we presented that Amphenol actually went to do some analysis by changing the opening for this finger part, that they actually can make the card insertion mechanical tolerance to be from the 31,000 dBPM down to like almost 5. So the same thing was done by TE, and then TE came back with the analysis. They are actually similar to Amphenol. They agree with Amphenol that we're gonna move this slot from the slot width from the 1.85 to 2.1 millimeter. So we have 2 connector vendors running independent analysis. Yeah, and then they are aligned. So our mechanical draft will be updated to this. Actually, I do supposed to have a new mechanical file. I think within a few days. There was one, but I think there are some mistakes. We are rechecking it. And then regarding our SI work stream, so Intel have simulated the DSFF for the motherboard routing. At this time, this analysis is able to make the 7 dB insertion loss target for Gen 5 to work. So that will be our basis. During this study, we also realized that due to the bottom keep out zone for adhesive, like basically from this particular rectangle box here, the AC caps are actually a little bit further from the gold fingers. This is something that the SI group is actually asking the mechanical group to see whether we can do some optimization in this so that AC caps can be closer to the gold finger for SI reasons. Yeah, this is something still open that we need to close, whether it can be done or not. Yeah, and especially when we move to Gen 6, I think that is also important. Yeah, so those are the couple updates for this month. There are other things that we need to discuss further before we bring it up to a server group for further discussions. That's all from me this month.
All right, thank you, Damien. Any of you have any questions or comments for OCP NIC subproject? All right, thank you, Damien. Next up, we
Thanks,
have
John.
Song on OAI OAM subproject.
Hey, John.
Yeah.
I'm just going to provide a verbal update from where we stand right now on the OAI. And we pretty much finish up the OAI 2.0, right? Or the contribution data sheet, right? Spec has been in the OCP database. And I'm going to update the wiki page today so that it will reflect the latest update. I think this is what we have on the 2.0 status. In terms of the OAI 3.0, and I think we have been exploring a few things in the work stream, like in the past couple months. But I think we need help from the OCP community, right, on how to drive the 3.0 moving forward, because the scope of the 3.0 is quite huge, and we'd like to get more alignment between the OCP community on how to drive the 3.0. Yeah, I think this is the latest status, John.
Okay. As far as ongoing meetings, can you make some comments about what meetings you're having and what the schedule of those are?
I think in terms of the work stream meeting, right, I think we have like a monthly cadence right now, but we need to align with OCP, because if for 3.0 we're going to go with the CLA process again, right? But we do need to have more contributor from the hyperscaler and the CSP so that we can drive the specification. And right now in the work stream, we basically is kind of in the idle right now. We are not talking about we are not discussing about any 2.0, because I think so far the spec has been published on the OCP database. We do not really have any feedback from the community. As I understand that a lot of the use case, right, and has been adopted in China market very broadly for the 2.0.
Song, can I ask a question?
Yes, Alan.
So just on the 2.0, is there platforms readily available and for interoperability? So I'm consulting with a startup, specifically Next Silicon, that have an OAM module. They have a version 1.5, and I think they're developing more. But they're facing significant challenges in buying. There's lots of platforms out there from, all the vendors like Supermicro, etc. But when they talk to any of them in terms of using their platforms, they get a response back saying we need to design a specific UBB for you because we will have interoperability issues. And so we're talking multi-million-dollar efforts, which doesn't sound like an industry standard. So it with V2, I'm not, now, to be honest, I'm one step removed, so I don't know if this is a version 1.5 issue and it's been resolved with version 2, or it's a version 2 and 1.5 issue. So is AMD and Intel, are you providing some level of access for us third-party companies to be able to, well, first of all, does AMD UBBs interoperate with Intel ones and vice versa? And assuming they do, and the OCP spec has interoperability in mind, can third parties come into this and work with us under OCP, so we don't all have to spend, because every single startup having to spend multi-million-dollars for their own UBB is never going to be sustainable in terms of making OEM an industry standard. So is there something we can do about that?
Yeah, let me just talk about this, right? I think the goal for the 1.0, right? We try to having a common UBB that every OEM can drop in and to be use the same UBB, right? But the trend in the AI or HPC, right? I think the 2.0 side, mostly the UBB come along with the OEM. It's not going to be interop with any other OEM because first is the topology is different, right? The second one is the control mechanism on the OEM and UBB was slightly different, depends on the OEM design because that is a closed loop design. The third one is more on the software, like the out of band, because different vendor will have the different out of band in terms of the register accessing, right, and management. So normally the UBB OEM are not interop with other one, right? Just like AMD UBB, the Intel cannot use that because of the topology is different, right? And all the routing is different. And also some of them depends on the OEM SerDes capability. Are they targeting for 112 gig? Are they targeting for 56 gig? There's a lot of the different there, right? A lot of UBB, the design tends to meet their own specification. They're not intend to over design the whole thing because if you look at the UBB 2.0, we can support the 112 gig, right? But some application they only target like for 32 gig or 56 gig, so that they are not going to go with the expensive material. They only target for their own use case. So it's going to be hard to be UBB and ON to drop in compatible. That is one of the big reason.
So that's pretty. I mean, so basically that rings true then with what my startup is hearing from all the platform vendors. So thank you for the frank clarification. I mean, topology is one thing. Their need is very minimal. It's just a PCI connection, which is a PCI SIG thing, and just a simple network expansion. So topology is not the issue for them, but all those other things you just raised, and the fact that you're stating that there's not even compatibility between AMD and Intel UBBs. I mean, it doesn't bode well for the industry standardization, is what I'm saying. And it looks like it's too late for 1.5 and version 2. Is that correct? The only way we could correct this is version 3.
No, I mean we are not going to try to constrain like all the UBB have to work with all the OEM, right? Because it's not just a platform implementation. I think overall the system implementation as well, right? The cooling, the power delivery, etc.
Yeah, I understand.
Yeah.
I understand that. But the IBM PC has supported PCI cards for 40 years, and we've been able to plug anybody's PCI cards.
Oh no, I mean, okay. If you just talk about the PCIe, you definitely it's going to be
I understand, but my point is, we've lived off of successfully, I hasten to add, for 40 years off the IBM PC from 1981, and servers are still essentially the same today. But we've clearly needed to go majorly adrift from that with the changes in computing architecture, with thermal management and bisection bandwidth needs. And so we need an IBM PC for today's compute needs for everybody. And the hope was that OCP was driving that, but all we're driving, I mean, even if there was something for the rest of us, the fact that every startup has to spend millions of dollars to get a platform to plug a module into is untenable.
So if you look at this way, Alan, for the 2.0, right? The goal is that the UBB 2.0 is drop-in compatible with HGX baseboard, right? It's no longer a single OEM. You have to be bundle OEM UBB. Any system out there with HGX, it should be drop-in compatible as long as it meet the form factor requirement. I mean the I/O connector, right, to the motherboard or to the PCI switchboard, right, is compatible. So I think
But
Okay, well,
each
so
vendor would have to
hopefully our
develop their own
PCI
UBB.
switch should work.
I'm
Sorry.
sorry.
Hopefully our the PCI switch, you're saying the PCI connection from any vendor should work, is what I think.
Oh yeah, it should work. It should work. It's just a basic PCI standard, right? But the other thing is that it's not just PCI. In order to recognize the OEM, you need to work on the BMC side, right, and also the OS side, so that you can recognize this card. Because if there is a brand new card, nobody know what the card is, right? Is it
Well,
an accelerator or something
that can be
right?
dealt with on an open source software, which is, I'm assuming, OpenBMC and all that.
No, that's what I'm saying is that if you want to go to work with the system vendor, they're not going to provide that flexibility for you, right? You have to redesign the whole thing unless you want them to support you to enable that particular OEM vendor. There are certain amount of work to be done there.
Okay,
It's not just the
right.
hardware.
Well, okay.
Yeah.
Thanks for the clarification. I mean, it's a bit depressing. I don't know what others think about it, but I don't know. It doesn't make sense to go OEM in my mind.
Yeah, I know the DCMHS has had similar discussions where the spec is broad enough to allow multiple companies to develop MHS platforms, but those different options in the spec make those platforms incompatible sometimes. I know in MHS there's another initiative trying to define specific. I forgot the name. Sean, do you remember the name that we're talking about?
There's the plug and play work stream within DCMHS. Likewise, within DCSCM, there are the type definitions. Both of those efforts are intended to reduce the effort needed to bring a new HPM or DCSCM online. Nonetheless, the specs are both DCSCM and DCMHS are remove a significant barrier when having to take in new HBM designs or to apply those HBM designs across a number of different systems. I appreciate that the challenges that Song is noting with differences from implementation to implementation with UBB 2.0. Nonetheless, having a form factor to begin with, a physical form factor, is remarkably an improvement in the situation.
Yeah, said another way, both the OEM and the MHS specs have a lot of options and that you can choose either way. With MHS, they've started to define types that lock down some of those options to give a much better chance of having hardware compatibility.
Yeah, and Alan, just for consideration, the comparison back to the original IBM PC and the ISA cards. So yeah, I mean, we've gone through 4 or 5 different standards since 40 years ago. Nonetheless, we're dealing with UBB. You're dealing with a rapidly evolving ecosystem with AI, and rapidly evolving, it does make standards a challenge.
Yep. Oh,
Yeah, so
that's what we have.
hopefully if we get to some kind of plateau, we can start, defining types and making it more compatible. But, we're doing the best we can, and when it's moving as fast as it is, getting the mechanical compatibility is, like Sean said, is remarkable in itself.
Well, in UBB, UBB 1.0, et cetera, very well was going to be the answer with GPUs for general computation, but with AI, the AI explosion, or I'll contend the AI explosion that is just now beginning and will continue for a long time. It's going to be a changing landscape.
Well, that's where simplicity is the ultimate beauty. I guess I was always concerned that UBB fixed you to a topology in a particular box, and even if we look at machines like Frontier and Summit, you're being locked into a particular topology of GPU, CPU, and interconnect between those devices, which means nobody can sell those. IBM have given up on the game in terms of trying to sell those boxes to anyone else because they're so unique to specific application requirements. So that's what we're trying to do in the HPC sub-project. We're trying to say, keep it simple, stupid. Simplicity is the ultimate beauty. We just design a module, and you cable those modules together to your specific topologies. So, it just strikes me this conversation means that what we're doing in OCP HPC is the way we should be going for OAM version 3. So, Song, I'll be happy to join your discussions if you're looking for further input.
Yeah,
All
will
right.
do, Adam.
Yeah, thanks a lot, Song. I
Thank
need
you.
to get moving here. We're actually going to use the whole hour and maybe be pushed on time. Next up, we have Manoj on the CMS sub-project.
John, this is Manoj here. Hello?
Yeah, we can hear you.
Okay, all right. Just quick update. I don't have a slide that I prepared for this today, but as we talked about last time, we have 5 working groups. Out of those, 3 working groups have now the one which works on the workloads and benchmarks, computational programming API models, DXP, and then the academic research and innovation. All these 3 groups are up and running with their own work streams, Zoom calls, and we also have taken up GitHub as a repository for all our technical contributions from benchmarks and results point of view. The remaining 2 groups are in the process for setting up their regular rhythm for the work stream. One is which is for the AI HPC systems, and then the second is for the system architecture framework. We have a lot of discussions and presentation in that area. We will have contribution to the regional OCP with to the innovation village, and also we'll have a presentation to provide summary status update for CMS. Since not all the members are, or not majority of members are not going to be able to make it to regional OCP, we are thinking of a face-to-face tech day kind of for CMS in first week of May. So this is still work in progress. We are at that point, we want to take an update on where we stand on our overall goals for the year that we started off, and provide status in second week of May for where the progress is and what's the plan, so that we can work towards completing those goals by global OCP later part of the year. So that's our current plan right now. Any questions?
I'm looking at the wiki on the 5 work streams with their separate spaces. It looks like the wiki is out of date. It doesn't actually cover those.
Good point. Let me take an action.
Would you work on getting the wiki up to date and give links to the different work streams,
okay,
so people can keep track of that based on the wiki?
Very good feedback. We'll definitely fix it in next week.
Okay. Anybody have any questions or comments on CMS? All right. Next up, we have DCMHS. Sean, you want to share, or are you just going to talk?
Yeah, I'll share.
Okay.
Okay, couple updates. I'll let everybody read for the details, but I just want to cover a couple quick things. We are focused on getting a release of the SDINO spec to a 0.9 by the end of April. The internal numbering nomenclature that we use is a 0.9 means it's effectively done, and everything between the 0.9 and the 1.0 is for typos, clarifications, and that it's not a fundamental change on anything. There are some minor updates that we're making to the full width and the regular Dino specs. A lot of this is for either adding clarity or harmonizing with the SDINO spec. Each of the other specs continue to have just general updates or maintenance type of improvements, clarification on impact with power-up failures, labeling, so relatively minor stuff. The 48-volt addendum is something that is evolving and mostly aligned to the SDINO, since that's where we'd expect for implementations with Open Rack that has 48 volts. And then just continuing down, MCRPS is continuing to go through maintenance. We have a release candidate for the 1.04. And there are a number of design specifications that are being worked in order to help just provide a finer implementation and having a rich ecosystem of highly compatible power supplies. And then last, we talked about this earlier, the plug and play work stream. This is focused on helping to improve interoperability between different HPMs and different platforms. This is mostly focused on the deeper details of how DCSCM and other things interact with the intelligent devices that are on the HPM. So this, back to Alan's earlier comments, this helps to further push interoperability through the industry. That's what I have.
Thanks, Sean. I'll take a closer look at that.
Okay, we'll put this out in the notes from John.
Thanks.
All right, and all those updates are either in the wiki if they haven't been accepted, or in the contribution database if they have. So you can look both of those places if you're looking for the latest. All right, finishing up the external PCI connectivity. I don't think we have an update that's as needed. I do see Tom, you're on. Do you have a SIOV update?
Yeah, I'm here. Sorry, took me a minute to get off mute. I do have a quick update. Let me just share. All right, can you see an SIOV R2 working group update?
Yes.
Okay, great. So I just wanted to, this is kind of just a quick status update. I'll be quick about it. But so one of the big things that the team has been working on is the context identification piece of this, which is really what is necessary kind of on the wire, and we're targeting to bring that into the PCI SIG. So all of the, I think as everybody knows, right now it is a closed CLA that is operating, and all of the members are PCI SIG members on purpose, because to bring something to the PCI SIG, you can only do that as a member company. So as individual member companies, the plan is to bring in an ECR that basically brings this context identification in for the elements that we believe are necessary for the IO virtualization to work, to scale, and to operate on an IO device using the PCIe protocol. And so that that is in work, and you can see down at the bottom. I'll just kind of fast forward to, we're looking for mid to late Q2 where we actually submit that to the PCI SIG. But in going up a bullet, in parallel or in addition in sequence, we continue to work a lot of other details that we expect to be part of the OCP contribution that kind of ride above that PCIe layer, which get into the RAS, the quality of service, peer-to-peer, live migration, and some of the software architecture. So we are on, we reviewed our schedules and looked at, what we believe is feasible and the timeline. And obviously we're dependent on how things go through the PCI SIG as a piece of the puzzle, but we're targeting to be able to get that ECR in Q2, and then have a draft of the review of the rest of the document that I talked about in late Q3, with an intent to be able to get to a full publication and contribution in early next year. So, so this is we were on a kind of an end of year timeline, so we slipped a little bit, but this is our new schedule and update that I wanted to give to the team.
All right, thanks, Tom. And do you have any questions or comments? All right. Last on the agenda is kind of a cross-project coordination with the hardware management. They have released the 1.5 of their Run BMC, and they're working on some LPTI stuff with CPLD and component replacement for DCICM 2.2. And they're doing having some input on their common circuits work and the DCICM multi-node. Just like to keep track of what the hardware management project is doing, because it is so closely tied to server. Some of the details of those are in the status update link in the minutes if you want to get more details on that. I think that's all we have for today, and looks like we're right on time. Maybe you have any questions or comments before we close the meeting? All right. Thank everyone for joining, and we'll talk to everyone next month. For those who go to the summit, let us know how it goes.
Thanks, John.
Thanks, John.